Now we are into the summary of this chapter, mechanical properties of solids, and I will read each point and try to revise what we have discussed and their application. Stress is the restoring force per unit area, and strain is the fractional change in dimension. In general, there are three types of stresses: tensile stress, longitudinal stress associated with stretching, or compressive stress associated with compression, shearing stress, that is when the force is applied tangentially, and hydraulic stress when the medium involved is a fluid. For a small deformation, stress is directly proportional to the strain for many materials. This is known as Hooke's law. The constant of proportionality is called modulus of elasticity. Three elastic moduli, Young's modulus, shear modulus, bulk modulus, are used to describe the elastic behavior of objects as they respond to the deforming forces that act on them. A class of solid called elastomers does not obey Hooke's law. Elastomers are mainly the tissues and hard tissues, that one example given there, but there are many, all tissues will not obey the Hooke's law. When an object is under tension or compression, the Hooke's law takes the form of F by A equal to Young's modulus multiplied del L divided by L, where del L by L is the tensile or compressive strain of the object. F is the magnitude of the applied force causing the strain. A is the cross-sectional area over which F is applied perpendicular to A, and Y is the Young's modulus for the object. The stress is F by A. A pair of forces when applied parallel to the upper and lower faces, the solid deforms so that the upper faces move sideways with respect to the lower. The horizontal displacement del L of the upper face is perpendicular to the vertical height L. This type of deformation is called the shear, and the corresponding stress is shearing stress. This type of stress is possible only in solids. In this kind of deforming, the Hooke's law takes the form F by A equal to G into del L by L, where del L is the displacement of one end of the object in the direction of the applied force F, and G is the shear modulus. When an object undergoes hydraulic compression due to the stress exerted by surrounding fluid, the Hooke's law takes the form P equal to B del V by V. Here B is the bulk modulus of elasticity, and del V is a change in object volume, and V is the original volume initially, and P is the pressure. You can pressure and stress almost has the same dimension. Now the points to ponder: in the case of wire suspended from ceiling and stretched wire, the action of weight F is suspended from its other end. The force exerted by ceiling on it is equal to opposite to the weight. However, tension at any cross section A of the wire is just F and not 2F. Hence, tensile stress, which is equal to the tension per unit area, is equal to F by A. Hooke's law is valid only in the linear part of stress-strain curve. The Young's modulus and shear modulus are relevant only for solids, since only solids have length and shapes. Bulk modulus is relevant for solid, liquid, and gases. It refers to change in volume when every part of the body is under the uniform stress so that shape of the body remains unchanged. Size changes, shape remains the same. Metals have larger values of Young modulus than alloys and elastomer, and materials with a large value of Young modulus requires a large force to produce a small change in its length. In daily life, we feel that material which stretches more is more elastic, but it is a misnomer. In fact, material which stretches to lesser extent for a given load is considered to be more elastic. In general, a deforming force in one direction can produce strains in another direction also. The proportionality between stress and strain in such situation cannot describe by just one elastic constant. For example, for a wire under a longitudinal strain, the lateral dimension, radius, and cross section will undergo a small change, which is described by another elastic constant of the material called Poisson's ratio. Stress is not a vector quantity, unlike a force. The stress cannot be assigned a specific direction. Force acting on the portion of a body on a specified side or its on a section has a definite direction. So now we have read the summary, some misinterpretation, interpretation. Before exam, I will suggest you, if you have just one night, go through the summary and points to ponder. Thank you for then this chapter. Officially, the theory part is over for this chapter, and now Q&A section coming from next lecture of this chapter. Thank you for be with us.